In this topic, we'll be looking at the Pythagoras term. So, through the use of a video, which is this one here, explanation, students will be able to identify the parts of a right angle triangle. Okay, recall Pythagoras term and use or apply Pythagoras term to solve problems. Okay, so that is our key point here. So let's start. Well, first of all, identify the parts of a right angle triangle. So let's start. Consider the triangle here, and we have this triangle here as a right angle triangle, which means that this is 90 degrees. Okay, if this is 90 degrees, we notice that there are three sides to this triangle. So the sides that we are interested in are as follows. The longest side is known as the hypotenuse, and the hypotenuse you can identify it by two ways. One, hypotenuse is always opposite to the right angle, or opposite to the 90 degrees. That's one. Two, it is always the longest side of a right angle triangle. So let's write that down. Hypotenuse, two ways we could identify it. Its opposite side to the 90 degrees angle. That's one way. Point two, it is the longest side of the right angle triangle. Okay, so those are two key points there. How to identify the hypotenuse. It is the longest side and it is opposite to the 90 degrees. Now the other two sides are just simply sides. Okay, so this is side, a side is another side, so we just call them sides. Sides, sides. Okay, so now let's go and see what is hypotenuse. It is a formula to identify the length of one side of the three sides of the triangle given two known sides. Let's see how this works. So we have a triangle now there. This is the right angle, and you are given here 3 and 4. I won't put units so as not to stay restrained to that unit only. Just consider it is to be 3 centimeters or meters, as well as this to be meters or centimeters. So it's just simply that amount of units. We will call this triangle ABC. How you label it, that's up to you. So you put here A, B, C. This side here is opposite to B. This side here is opposite to A. This side here is opposite to C. So we can label this side to be C, this side to be A, and this side to be B. Based on the diagram that you get, you might label it slightly different. Nevertheless, the longest side is still the hypotenuse. So I'm going to formulate my formula of hypotenuse from here. So Pythagoras term tells me, according to this is telling me that this side, or this side here, which is the hypotenuse squared, is equal to the sum of the other two sides being squared. That's what Pythagoras term tells me. Okay, so don't stay restrained to these letters. It is only a label for the sides of the triangle. All right, so we can solve for the longest side here. So let's see how this works. If we have a right angle triangle where a distance AB is equals to 3 units and the distance BC is equals to 4 units, what would the distance AC equal to? Well, according to this is what we would do. We would keep AC as unknown. AB is actually 3 squared plus BC, which is 4 squared. Okay, and so we put down AC squared equals 3 squared is equals to 9 plus 4 squared is equals to 16, and so AC squared is equals to 25. But that's not the end of the problem. We need to find the square root of this side so that we get rid of this square sign. So we square root both sides, and that gives us square root 25, which is now equals to 5 units. Okay, and we have found the length here to be 5 units for that particular triangle. So let's go over what we just did. We got a triangle, and we were told that AB is equals to 3 and the other side was equals to 4. So we recall Pythagoras Term and we apply the values into the equation. How did we do that? Well, let's see what were the given values. The given values were these sides, not the hypotenuse. So therefore, in this case, the hypotenuse was the unknown. So when you are looking for the hypotenuse, that will stay on this side by itself, and you just add, you square and add the sum of the other two numbers, and then find the square root. That is how you find the hypotenuse length. So this was when we were looking for the hypotenuse. Let's look at another example. Okay, and this other example is one as follows. Consider a triangle. Okay, and I'm going to label this triangle here X, Y, Z, where this is a right angle. That symbol represents it to be at 90 degrees. So in this case, you are given the hypotenuse to be 10 and one of the lengths to be 7 units. Okay, so then how do we solve this? Well, you will need to solve this by applying Pythagoras Term. So in this case, recall what is Pythagoras Term. According to this, which one will be the hypotenuse? Because that needs to be by itself. Well, the hypotenuse here is xz. So you put here xz squared is equal to the sum of xy squared plus yz squared. So let's see what we have been given and what we need to solve. Do we have xz? Yes, that's 10. So we substitute there. We put here now 10 squared. Do we have xy? Yes, which is 7. So we put 7 squared plus yz squared. So this is the unknown. So what we do now is that we solve, we rearrange, we do our valuing evaluation. So 10 squared is actually 100, 7 squared is actually 49 plus yz squared. Bring the 49 over, we end up with 100, take away 49 equals yz squared. Okay, so now 100 take away 49, that will give us 1,951 equals yz squared. So now find the square root of both sides. We know that yz is equals to the square root of 51. Now here is where you will need to use your calculator. So you bring your calculator and you will find the square root 51. Here is my symbol for square root. So I punch that in, and you notice here at the top it appears the square root symbol. So the number is 51, and then I press equal. I end up with 10.1414284229. Because I was never told to round off my value or specify my value to a specific number of decimal place or significant figures, you need to choose a point or a spot where you want to round off. Since we are science students, in this case, we are working with lone whole numbers, so to be one more unit accurate, go to 1 decimal point, and to 1 decimal point our value would be 7.1. So we bring here and we put that yz is equal to 7.1, and you put the unit and you put 1 decimal place, or this is two significant figures, and that is our solution for that one there. So this is when you're looking for one of the unknown sides.